If we want to graph y equals log of x, that's y equals log base 10 of x. And the easy way to do this is to figure out first where the vertical asymptote is by setting the stuff in parentheses equal to 0. That's because you can't raise 10 to any power to get 0, but you can raise 10 to a power to get really small numbers. So that's what gives us the vertical asymptote. So we get x equals 0 for that vertical asymptote. Then the next step is to set the stuff in parentheses equal to 1. So that just gives us x equals 1 in this case. And that makes y equal to 0. The next thing is to set the stuff in parentheses equal to the base. And the base here that's understood to be there is 10. So we get x equals 10. And that's at y equals 1. So we've got x equals 0 makes y not exist. X equals 1 makes y equal to 0. X equals 10 makes y equal to 1. We plot the 2 points that we have, and we plot the vertical asymptote, and that gives us a pretty good sketch of the graph. Graphing y equals the natural log of x is graphing y equals log base e of x. And so the fast way to do this is to set the stuff in parentheses equal to 0, equal to 1, and equal to the base e. That will give us a vertical asymptote. That will give us the place where the y value is 0, and then the place where the y value is 1. So we get a vertical asymptote at x equals 0, since the stuff in parentheses is just x. We get an x-intercept at x equals 1, and then we get y equals 1 when x equals e. So we can plot this thing pretty quickly. E, remember, is a number between 2 and 3. It's about 2.7. So it doesn't have to be perfect. Just pick where you think around 2.7 would be, and that's E. And this graph looks really similar to the graph of y equals log base 10 of x. It just increases a little faster. It hits y equals 1 at e instead of at 10. But they both have the vertical asymptote at x equals 0. And then for log base 2 of x minus 3, when we set the stuff in parentheses equal to 0 to find the vertical asymptote, we get x equals 3. When we set it equal to 1 to figure out where the x-intercept is, we get x equals 4. And when we set it equal to 0 to find out where y equals 1, I'm sorry, not 0, to the base, which is 2, we get x equals 5. So vertical asymptote at x equals 3, x-intercept at x equals 4, y equals 1 at x equals 5. And if you remember from transformations of graphs and how those graphs can shift around, you can tell that this is just going to be the graph of log base 2 of x, but it will be shifted to the right 3 units. So that's another way to see why you're getting a vertical asymptote at x equals 3. If you have any questions about graphing logarithms, feel free to leave a comment or a question on this video, or feel free to email me.